40 in the network section of the 2026 NHT paper. The first question talks about water flowing through series of pipes in an estate from the source to the sink, and as shown in the directed network below, the number in each edge represents the capacity in megaliters per hour. Determine the capacity. So as far as the capacity is concerned, you have to take all the edges that flow from the source to the sink. So if this is the thing, and that is your source, and that's the sink, and that's your cut, as long as it's in this direction, you are to include it. If it's in the opposite direction, you exclude it. So what I usually do is I mark all the edges that it cuts and where it cuts, and then I look for the direction of the arrow. It goes this way, so 18 is included. 32 goes, yes, source to sink, included. 17 also goes from the source to sink. That is your source side, okay? So as long as it goes from the colored region here to the opposite region, you include it. And then 17 also goes from source to sink, include it. Now 18, okay, goes from the sink to the source side, so you exclude it. And 37 goes from the source to the sink, include it. So when you add these values, 18 plus 32 plus 17 plus 37, it gives you 104. So that's your very first answer. Now let's look at the second one. A cut passes through 4 edges and has a capacity of 109 per hour. Find the cut. So in order to do that, I tried to look for some really big values, because if there's 4 values, that's got to add up to 109. I started from the left, and I saw okay, if I was to do this cut, it was only 3 edges, and if I was to do the next cut, I would say that's 1, 2, 3 and 4, but I think that doesn't add up to 109, and so let me try another one. 1, 2, 3, and I come down here. So that are big values: 40, 35, 16, 18, and when added gives me 109. This is a bit time consuming, but you'll get there anyway, because it's in the very beginning of the network, okay? In order to answer question B, we can adopt many methods. I'm going to do the cut method, where you go from the top edges to the bottom edges systematically, and you look for the lowest values along every path. So if you look at the first one, which is that one, 18 is the smallest value. So the idea is to say that even if 27 reaches here, only 18 will flow through here, okay, and reach maximum capacity. And so basically 18 will flow through here and 18 will flow through here. So we're going to use that idea and indicate the paths where maximum capacity has been reached, and that will tell us that no more water can flow through those pipes, okay? So as we discussed, 18 is the smallest value along that edge, and so we subtract 18, take away 18 will give you 0. That means no more can pass through. And then 27 take away 18 is 9, and 33 take away 18 is 25, and 19 take away 18 is 1. So we write 18 on the side over here, or we can say yes, 18 reached here. And then we look, so then usually what I do is I highlight the 0, and now that indicates to me that basically there can be no flow in that direction. Okay, so let's now look at another path. Because there's a capacity of 1 over here, and I know that we can take that particular path, the lowest value along this path is 1. And so if 1 has been reached, so that'll leave me with 0 capacity here, and that'll leave me with 24 here. That'll leave me with 31 here, 15, and 8. And so 1 has gone through. Okay, the edge that has reached maximum capacity here is this one. So going across this particular edge is really no use, because you will come to a capacity edge which is currently 0. Okay, so we can cancel that edge and not bother going across it. And now if we go through, the edge that we can now look at is the smallest value we know that if we went across this particular path, okay, the smallest value is 8. So we'll say another 8 reached here, and that means that has a capacity of 0 left. That leaves you with 7 over there. That leaves you with 23 over here, 29 here, and 4 there. Now, which edge has reached maximum capacity? It is this one. So that implies that if no water can flow through here, that implies that this edge is not going to get any water. And so we can cancel this particular edge, okay, as an edge that really will not have any water flowing through it. So now let's look at the remaining edges. We can see that 4 is a small value here, and so we can actually look at this path, okay, and it's no use going here because we have a backward flow here. Okay, so if we went along here, we went along down and we came this way, we could allow 4 to go through. So let's say 4 went through, so that's a 4 there. That's a 4 that reaches here. That leaves us with 25 here. That leaves us with 19 here. And we came along here, so that is 39, and that is 36. So the edge that has reached maximum capacity now is this one. So it's no use having pipes that lead to that, because it's ultimately going to not be allowed to pass through. So that helps us cancel this one. Now this edge also, even though there's still a capacity of 19 left, because it comes to this point which from then on really can't pass any more water through, and so we can then look at any other edge. Now this is a backward edge, okay, so, and that's a backward edge too, so we cancel that. Now let's look at any path that will allow water to flow through. So if we came along here, that's a dead end. If we came along here, this is a dead end, and that's a dead end too actually, because it goes backwards. So we can cancel that as well. And so that leaves us with one last path, which can actually go this way, down and through here. So the lowest value along that path, now you have to systematically come top down, okay, otherwise chances are you could make mistakes. So 18 is the lowest value. So let's say 18 reaches here. So 40 take away 18 is 22, and 37 take away 18 will be 19, and this one reaches 0. Now we came down 27, so that's 9 left, and that take away 18 is 21, and that take away 18 is 18. That's 36 take away 18 is 18. Now the edge that has reached maximum capacity is this one. Now even though there are remaining capacities that can go through, for example, we have that one, but all of them will need to pass through this edge, which is not possible, and so that tells us that we need to stop at this point. Now if we added all these values, which is these, we would get 49, and that is the answer to this question, part C, which asks you for the maximum flow. Thank you. Bye.